Welcome to Lesson 4 of the Optics Unit, Images in Plane Mirrors. Our goal for today will be to understand what an image will look like in a plane mirror. But first, let's review a little bit. We did talk about plane mirrors briefly in the last lesson. In optics, a plane mirror is one that is perfectly flat and smooth. You'll probably find plane mirrors in your bathrooms. Please note, in the real world, plane mirrors are never perfectly flat and smooth, but we can assume they are, and therefore they undergo specular reflection. So to practice, we'll use the law of reflection in the plane mirror shown below. We have an incident ray of light on the left, the mirror is shown below, the reflective surface is on the front, and the non-reflective surface would be on the back. Remember, the normal is always perpendicular to the surface. This is shown next. The normal is perpendicular to the surface, so you can put a 90-degree angle to show that. And we always measure the angle of incidence relative to the normal. So that would be the angle between the incident ray and the normal, shown over here. We'll make up an angle, let's say 48 degrees. And according to the law of reflection, the angle of reflection is equal to the angle of incidence. Okay, so just something to take away again. Angle of incidence is equal to the angle of reflection. Alright, and this is true for plane mirrors, which we're assuming are perfectly smooth and flat. When light hits a mirror, it reflects, and that reflected light eventually makes its way into our eyes. Our brain then processes that light to create an image, and it does so using the light received. But when we're looking in a mirror, we're not actually seeing the object itself, we're seeing images of the objects. And these images are reflected in the mirror. So let's see how it works by looking below. So in the picture below, let's say we have a plane mirror. Remember the left side represents the reflective part, and the right side with the hashed line represents the opaque part. So let's say you're standing in front of a mirror getting ready for school. Here you are. We'll pretend that's an accurate drawing of any one of you. And we're going to form an image of you somewhere on the other side of the mirror. So to be accurate here, I'll copy and paste what I drew. Let's line it up and move it to the right. There we go. So that's the image on the right side. And the object on the left side being you. So how does this work? Let's see. As you know, you are not a source of light, but let's assume you have a source of light on in the room. That could be a light or maybe sunlight from coming in from a window. Now for simplicity, we're going to look at two rays of light. So let's imagine that there's one ray of light coming from the top of your head. It leaves the top of your head like so. According to the law of reflection, when it hits the mirror, it's going to reflect off of the same angle that it came in at. And it'll enter your eye. Let's also say that another ray from the bottom of your face, your chin, is coming up like this. It reflects off of the mirror at the same angle it came in at and eventually makes its way to your eye. So this is a very simplistic picture. In reality, there's hundreds of these rays of light, maybe more, that are entering your eye, and your brain is processing them all to make an image. But how does your brain see an image on the other side of the mirror? Well, here's what your brain does. It perceives it like the light is coming from the other side of the mirror, like so. Okay, you'll have to forgive me, I didn't draw this exactly to scale, but if I did, the dotted lines would perfectly line up with the top and bottom of the head on the image side. So this is a virtual image because our brain perceives it like the light is coming from the other side of the mirror, when in reality, it's not. Alright, and more or less, that's how mirrors work to form virtual images. Let's take a look at the picture below. In this case, we have a die sitting in front of 3 mirrors, and these are plane mirrors, so your eyes are going to see virtual images of the die. So here would be the object itself, and I'll just circle it to make it clear. Okay, and as you can see, we're forming images in the mirrors. So these are the images. And it looks like there's 3 dice on the other side of the mirrors, but in reality, there's nothing there, which is what makes it a virtual image. So how do we determine the image in a plane mirror? Well, we're going to use the property of light, that it travels in a straight line. So in the previous picture, the light from the die reflects off of the mirror and goes into your eyes. But as I mentioned before, our brains can't understand what reflected light is, so what it does is projects those reflected rays of light backwards to make it appear like it's coming from a source. Alright, so it's a trick. Our brains think that there's a light source behind the mirror, and we see the reflected image behind the mirror, but as you know, in reality, there's nothing behind the mirror. The mirror is attached to a wall, and there's definitely not an object on the other side of the wall. The wall is opaque, meaning light can't actually pass through the wall. Our brains can't actually comprehend this, so it believes the light is coming from a source, which is why we call these virtual images. So the key thing to take away is virtual images are always formed whenever the light rays aren't actually coming from a source. Okay, so to summarize, your eyes actually detect reflected light, but when your brain processes that, it's determining that the image is located on the other side of the mirror. And we'll look at another example below. So we have the object on the left side of the mirror, the image, well specifically virtual image, on the right side. This object is not a source of light, but assume that there is light in the room. So we'll look at a couple rays of light leaving the bottom of the pencil and a couple rays of light leaving the top of the pencil. So let's say we follow this ray of light from the top of the pen. Alright, so that ray of light leaves the top of the pen, bounces off of the pen at the same angle it hit the mirror at, following the law of reflection. That ray of light makes its way into the person's eye, but they perceive it like it's coming from behind the mirror. Let's do another one. Okay, so follow this ray of light. It leaves the top of the pen, bounces off of the mirror at the same angle it came in at, makes its way to the person's eye, but they perceive it like it came from behind the mirror again. So there's another ray of light coming from the bottom of the pencil. It reflects off of the mirror at the same angle it came in at and makes its way to the person's eye. But again, our brains perceive it like it's coming from behind the mirror. And finally, we'll do one more. Here's the original ray of light. It bounces off of the mirror, makes its way to the person's eye, but they perceive it like it's coming from behind the mirror. All right, and this is how everyday mirrors work. So just to summarize, when you see a reflection, the reflected rays of light are entering your eye, but your brain is processing it to make it look like the object is coming from behind the mirror. And what you can do is watch the following YouTube video. This will also explain what we just talked about. So this would actually be a good time to pause this video, watch that one, and come back to this video after you finished watching it. So please do so. And when you're ready, click play to resume. All right, you're back. So one property of images in plane mirrors is that they have something called lateral inversion. And lateral inversion is when the orientation of an image in a plane mirror is backwards and in reverse order. Okay, so we'll look at an example below. So if you have the letters A, B, C, D, E, F as the object, then for the image, the letters are in reverse order. So instead of A, B, C, D, E, F, it's F, E, D, C, B, A. But not only are they in reverse order, they're also backwards. And the same is true for this clock. So let's say that this clock is an image. I guess the original clock would look like this. Alrighty, so that's our original clock. I guess we can draw a clock hand as well. There we go. Hey, how is that? Not too bad, I would say. So look at the image now. You'll notice that all the numbers are backwards and they're in reverse order. So this is a property of all images in plane mirrors. Let's talk a little bit more about how we locate images in plane mirrors. So in the diagram above, what do you notice about the image produced? And what do you notice about its location? Let's discuss. First of all, notice that the image is the same distance away from the mirror as the object, and it's also at the same level. So what I mean by this is the bottom of the pencil is at the same level as the image, and the top of the pencil is also at the same level as the image. But they're also the same distance away. So if the bottom of the pencil was, let's say, 1 centimeter away from the mirror, then the image would have the bottom of the pencil also being 1 centimeter away. Okay, so we'll make a note of that. Okay, so in comparing now the image to the object, we'll make a note of two things we should notice. The distance from the object to the mirror is exactly the same as the distance from the image to the mirror. And one more thing to notice is that the line going from the object to the image is perpendicular to the mirror surface. All right, so let's look at an example in the picture below. On the left here, we have some object. It's just represented by a dot. And if the image is over here, then first of all, notice that these two lines must be the same distance. And secondly, the line connecting the object to the image is perpendicular. So this would be a 90-degree angle. Okay, and we can look at an example in the picture to the right. So the distance from the top of the pencil to the top of the pencil in the image would be the same. So these lines are the same. Similarly, these lines are the same. These lines are the same. And these lines are the same. Okay, and all of these lines are perpendicular to the surface of the mirror. So these properties will help you locate images in a plane mirror. All right, let's look at the following steps to locating images in a plane mirror. What you'll do is pick a few points on the object. This is entirely up to you, but pick nice points. At each point, you'll draw a perpendicular line from the object to the mirror. Do make sure it's perpendicular, that's important. Measure this line, so I guess what you'll do is use a ruler. So please actually make sure you have a ruler handy for this unit. And then you'll make an identical perpendicular line from the mirror to where the image will be, make a point there, repeat this process, connect them, draw the image, and then finally you can draw the light rays that would create the resulting image. This will be demonstrated in the example below. So what we're going to do in each of the following, we're going to draw the image for each of the objects. So in number 1, the object is just a dot. So assuming you have this printed out in front of you, draw a perpendicular line from the object to the mirror. I'll demonstrate this below. Okay, you have to make sure it's perpendicular. That's important. Secondly, assuming you have this printed in front of you, please measure the line that you just drew. It should be approximately 3 centimeters. All right, so what you do now is take that line, that 3 centimeter line, and draw an identical one on the other side of the mirror. I'll demonstrate this next. Okay, and place a dot. That's where your image will be. So just full disclosure, I'm doing this on a tablet, so I don't have the luxury of having a ruler in front of me, but you'll just have to trust me on this one, but please do so on a piece of paper if you have it printed out in front of you. Let's do the next one. All right, we have a more exciting object here, a pencil. So once again, what we'll do is pick a few nice points on the object. All you really need are two, let's say the top of the pencil and maybe the bottom of the pencil. Draw two perpendicular lines, one from the top of the pencil to the mirror, and the second from the bottom of the pencil to the mirror. All right, let's say you measure that, and again, we'll assume it's 3 centimeters. So you're going to reconstruct this line. So we're going to take that 3 centimeter line and draw it on the other side of the mirror. Make a dot. And we'll do the same thing for the bottom line. I'll use a different line here to indicate that. Okay, and now reconstruct the image. So don't worry if you're not the best artist like me. We just want to reconstruct the pencil over here. All right, close enough. But hopefully that explains what we're doing. So that top line should be 3 centimeters as well, and the bottom one the same. To help us describe properties of an image, we're going to use an acronym called SALT. Here's how SALT is going to help us describe the properties of an image. The S stands for the size of the image, but specifically compared to the object. So is the image the same size, is it smaller, or is it larger? A stands for the attitude of an image. What we mean by attitude is the orientation of the image. How is the image oriented relative to the object? Is it upright, meaning in the same position, or is it inverted? L stands for the location of the image. By location, we mean is it on the same side of the object or opposite side of the object? Okay, and finally, the T stands for the type of image. In other words, well, there really are only two types of images. They could either be real or they could be virtual. Real images are always formed when light is actually arriving at the image location. So, for plane mirrors, images formed in plane mirrors will always have the following properties. First of all, for S, the size of the image, they will always be the same size as the object. For the attitude, they will always be upright. But laterally inverted. As for the location, they'll be behind the mirror. And finally, for the type of image, they'll always be virtual. Okay, and let's summarize in the picture below. So here's our object. It's a tree. Okay, so for the size, so for the S part of the acronym, the size, it could either be, the image could either be larger, the same, or smaller. For the A part of the acronym, the attitude, it can either be upright or inverted. But remember, plane mirrors laterally invert. Okay, so as an example, let's say we have the number 30 in front of a plane mirror. Although the number 30 will be upright, it's laterally inverted, meaning the numbers are backwards and in reverse order. So we'll start with the 0 first, and then the 3, but the 3 will be backwards, something like this. Okay, so as for the location, we typically put objects on the reflective or shiny part of the mirror, and for this type of mirror, images will always be on the other side. But in some cases, you can form images on the same side of the object, not so for the plane mirror. And lastly, as for the type, either virtual or real. Remember, virtual means that your brain perceives it like the light is coming from a source that where it's actually not. And as for real images, the light would actually be coming from the location. Let's do some practice. Okay, so we're going to describe the characteristics of the F image. So this would be the object on the left, and the image is on the right. Let's get started. So for the size, I think it's pretty clear that the sizes are the same. As for the attitude, we can see that it's upright. And we'll also mention that it's laterally inverted. For the location, it's behind the mirror. And because it's behind the mirror, it must be virtual. All right, let's do another one. So what we're going to do for this one is draw the image for the following arrow and then describe the characteristics of the image. So this would actually be a great time for you to pause the video, pick a few nice points on the object. I'll actually give you a little bit of a hint here. I would take the top of the arrow, maybe this point, and the two bottom points there. So those 5 points should be more than enough. Follow the procedure we used previously, where you draw perpendicular lines from the object to the mirror. You measure that distance and then construct the same line on the other side and put your point there. Alright, so pause the video please, try to do it on your own, and when you're ready, click play to resume. Okay, you're back. So you should get something like this. Again, please forgive my not so great drawing, but as long as you follow the procedure, you'll get something fairly accurate. Now let's describe it. So first of all, as for the size, it's the same. As for the attitude, it's upright and laterally inverted. As for the location, it would be behind the mirror. Okay, and all of this makes it a virtual image. Okay, everyone, and that finishes the lesson. So please try the following worksheet for homework. Once again, any questions, don't hesitate to reach out. Thanks for watching the video, and we'll see you in the next one.